All right, we'll get people sorted. Hey, thank you for showing up for your learning. Here, we're going to go pretty quick through inverses of functions to learn this new material. Basically, what is it? Well, an inverse of a function is something that undoes the work of a function. Essentially, it takes the outputs of one function and turns them into inputs of a new function. What are the outputs of the new function? Well, they would be the inputs of the old function. Basically taking your x's and y's and flipping them. Okay? So, if we go back to my favorite function metaphor, a great function metaphor is the vending machine. I put in money and out comes chips. If I had a machine where I could input chips and out would come money, that would be the inverse of that vending machine function. Okay? Takes my inputs, turns them into outputs. That's all. All right. And we're going to take a look at how we do this graphically, how we do this point by point, and how we do it algebraically. Now, we write the inverse of a function with a special notation. You'll see it right here. Okay. And this to the negative 1 is not an exponent. So it's not this. No. In the same way that f of x is not take f and multiply by x. No, it's not this. So we know that this is a new type of notation for writing y equals. Okay. Similarly, this is not an exponent. It means just the inverse of a function. So, how do we define that? Well, if we had a function that mapped a to 3 and b to 1 and c to 2, the inverse of that function would just swap these two columns. That's all it would do. All it would do is take inputs and make them outputs. Okay, so the property is if f at a equals b, then f inverse of b equals a. Is just swap the positions of a and b. Okay, let's keep going. So let's use the definition of the inverse to find the inverse function for f of x is equal to x squared. We'll find this thing's inverse, but we're going to do it point by point. So here, what I'm going to do, you'll be amazed. This is just like if I have this point 4, well, that could be an input of minus 2. This one 1, well, that could be minus 1. 0 and 0, okay, 1 and 1, cool. And then 4 and 2. How did I do that? Yes, Miley, you are correct. You just flip them. You just swap your x's and y's. Oh, working point by point. So easy here, right? So easy. See how to do that? Now, there will be a question on the test that is like this, that is just that easy. So if it doesn't seem easy, watch again. I take this, x and y, and swap them into y and x. That's all. I take these two and swap them. These ones swap to themselves, those ones swap to themselves, but that one swaps there. Just like that. That's point by point. Any questions? Okay. Josh? Sure. Someone's phone is making music, maybe? Anyhow, let's keep going. Maybe it's another class. Now, if we want to take a look at graphing these, notice what's happened here, okay? So our original function, y is equal to x squared, or f of x equals x squared, we notice that it has a domain. So we have here, let's do the domain. X is of the reals, and that's it. This function goes off to infinity that direction and that direction in the x. I mean, it doesn't turn that way, but they do keep going. Okay. Y, it goes off to the infinity in the positive direction. It's also real numbers, but y is greater than or equal to 0 in the initial function here. In the inverse function, on the other hand, here's the inverse function, the inverse of that function. Is the inverse of y equals x squared, is that a function? No, it ain't. It ain't a function. Why not? Yeah, it doesn't pass vertical line test. It has multiple outputs for the same x inputs.
This is a normal thing, right?
No, I guess not. But what we notice is that now x is still real numbers, and x is now the one that's greater than 0. And in this case, y can get infinitely big or infinitely big in the negative sense. So y is now of the reals with no limitations. Notice that the domain became the range became the domain. Okay? Swap your x's and y's. It's a function of just flipping your x's and y's. All right? Okay? Now, there's a clue on this picture here. Notice this dotted line. If I had to give you if you had to give me the equation of that dotted line, what would it be? That's the line y equals x. And notice that the line y equals x is acting here like a mirror for the functions. And that this little bit that was spilling over on that side of the mirror, now it spills over on the top. This bit reflects that way. This bit here reflects that way. And all the points are reflected in y equals x. Because we swapped our y's and x's, so they go to opposite sides of that line. Let's take a look. So when we're working numerically or point by point, we want to remember the domain of f of x is the range of the f inverse of x. We read this as f inverse of x, and the range becomes the domain. And then the inputs and the outputs switch. Patrick?
This is just more of a curiosity thing.
Yeah.
To have a negative f of x, it would be f negative x. Or
A negative
to
f
have
of
a
x?
negative function, like you wanted it flipped on the axis.
Oh, if I want to like just reflect it in the line like the x-axis?
Yeah.
Oh yeah, then it would be negative f of x.
So
Would just reflect
would
it.
a negative inverse function be f negative 1 negative x?
But yeah, you could apply this as one of your transformations. I'm not going to ask you to do that, but you could say first we took the inverse of a function, then we flipped it in the x-axis, and then we compressed it towards the y-axis. Could do that. I'm not gonna, but I could. But you could do that. Maybe I'll put that on as a bonus question on the test. Huh? Bonus question. Okay, so notice that this table of values for f of x just got flipped when it became f inverse of x. So the 15y became a 15x, the negative 2x became a negative 2y, and so on. All of it just flipped. Super straightforward point by point. If we're looking graphically, and we say, well, this point here was on the line y equals x, and this point here was on the line y equals x, those map to themselves in the inverse. But if I take like a point here, and then I just go across the function there, I'll find that those points, the midpoint of that line is the line y equals x squared. If I go here to negative 1, 1, we knew that negative 1, 1 mapped to 1, negative 1 over here. So if I connect those points with a line, this would be the same as that. Like if I divided the line in half there, the midpoint is y equals x. So I can also take like this point here, let's say negative 2, 4, and I can reflect it over here to the point 4, negative 2. And so you can also work visually like this, reflecting through the line y equals x. So if we're going to work graphically, you just switch the domain and range of f of x to obtain the new domain, and then reflect it across the line y equals x. So if I had this function here, let's say I had a function that was just negative 2 maps to 1, and 2 maps to 7, and I graphed these points, I can reflect those points in the line y equals x to obtain these new points, and then that's my new function. And I might ask you to try that and practice that, finding the inverse of a function graphically. Okay, then how about if we did it algebraically? All right, this is I'm going to ask you to do this on the test with a quadratic. Oh, there you go. And there's an example in your practice test, and you'll see one. So we will try that today. How do we do it? Well, the first step is we're going to write the initial equation in the y equals form. We're not going to write it as a function. And then change the position of x and y in the equation. Just swap them. And then solve for the new equation for y. That's it. And then replace y with f inverse of x. There, you're done. So here you go. This is what we do. Let's try it. So let's try it with the line, and then we'll try it with the this one. And these examples you have in there, right? Okay, let's go. So f of x equals 2x minus 3. So my first step would be rewrite it as y equals 2x minus 3. Next, I'm going to do f inverse of x. Okay, I'm going to take the inverse, and I'm just going to note that I'm doing that here. X equals 2y minus 3. Aha, I swapped my x's and my y's. Now, let's keep going. I usually solve functions for y equals, so let's do that. I'm going to isolate y. I'm going to do that with my inverse operation pen. I am first going to deal with the loose addition and subtraction because I don't like to do things the hard way. I like to do it the easy way. So this is x plus 3 equals 2y, and then one last inverse operation to perform. Divide by 2 both sides. And I have my inverse all finished here. Almost. I have x over 2 plus 3 over 2 is equal to y. And then I can write that as f inverse of x. So I'm just going to say f inverse of x is equal to x over 2 plus 3 over 2. Done. Maybe I circle it. I point at it. I say, look, I found it, Mr. Jennings. And then I'm done. That is finding the inverse of a line. Now let's do this other one. Oh, nice. This one's already arranged in vertex form. Lines are easier to find the inverses when they're in vertex form. So if I gave you one that's not in vertex form, you might want to put it in vertex form. All right, so let's do it. First, we're going to write it as y equals. You can do it if it's not in vertex form, but you'll wish you'd put it in vertex form first. Okay, and then I'm going to do the f inverse trick. This is just a note I'm making to my reader that I am now not saying that this line is equal to the line above it. I'm saying that the f inverse would look like so I just swap them. That's my next step. Now I solve for y. Let's go. Get out my inverse operations pen. Deal with this loose addition and subtraction first. I have a new line. X minus 6 equals negative 2. Y plus 4 squared. And now I get out my inverse operation pen again. And I'm going to, first I dealt with the loose subtraction. Now I deal with the multiplication. Notice I'm working in backwards Bedmus order to turn this around. Backwards Bedmus order. So now I have x, negative x over 2 plus 3 equals y plus 4 squared. All right. Now I'm going to deal with that exponent. So I'm working backwards Bedmus order. First addition, subtraction, then multiplication and division. Then I deal with the exponents. The last thing I'm going to crack is inside that bracket. So that's how I'm going to do my inverse operations. I didn't just give you instructions to do Bedmus backwards. When you're doing inverse operations, it's a strategy to solve for that variable that's buried inside the deepest layer of Bedmus. The deepest layer of Bedmus sounds like a horror movie. I don't think we'll have it ready for this horror movie season, but I take the square root of both sides. I take the square root of both sides, and when I do so, I need a plus minus on the opposite side. Because that's the inverse of taking the square of something, is take the square root of it. That will undo the square on this side, giving me y plus 4. This is equal to y plus 4 on that side. And on this side, I have plus minus the square root of negative x over 2 plus 3. And then one last glorious inverse operation. We finally get to deal with what was inside that bracket the whole time, minus 4 there. And so then we have plus or minus the square root of negative x over 2 plus 3 minus 4 equals y. Oh, and I could, instead of writing equals y, let's write equals inverse f inverse of x. Okay, and I asked you to verify graphically. So let's take a look. One problem with this here is I factored out that 2, and I wish I hadn't. Why did I do that? Oh, no, not to do that in the afternoon. Let's write this as a transformation. So do I have anything more down here? Apply inverses. Yeah, we're not going to do that example. There's our work for today. The last thing that I asked you to do is verify graphically. Let me write this out again here. F inverse of x is equal to plus or minus the square root of negative 1 over 2 x minus 6 minus 4. So I just factored that out so I could show it to you as K, C, and D there. All right, now let's graph that. So you have on your handouts the graph, and then you could also graph this function here. How would we graph that function? Well, I know that it's an x square root of x is its parent function, but we have the positive and the negative component of it. So that's going to look like a parabola on its side. And then it starts at x is positive 6 and y is negative 4. So it's going to start over here. It has been flipped in the y-axis. So it should look like this. Like that. So let's take, and so check that on your graph and see that it's indeed looks like a reflection of this guy through this line. So try graphing it. And then what is your work for today? Try these ones. And any questions, bring me over to your tables. And I will do one more example on the backboards of, or on this sideboard here, finding the inverse of a quadratic. All right. Bye for now, everyone.